gen applications with event-driven architecture. And so we're going to kind of climb into a few concepts. But before we do that, let me tell you a little bit about who I am. Excuse me. And I want to apologize right up front. I'm going to clear my throat into the microphone repeatedly. I wish I wasn't, but there it is. I lost my voice. Great timing, right before my first session. So I planned it that way. So anyway, my name is Eric Johnson. I'm a principal developer advocate for serverless. That's what I look like, if you can't tell. So that helps out. Big old picture there. I've been a developer for 30 years. I'm pretty old. I've been a solutions architect for 10, actually more years than that. I'm a big fan, and some of you may know this. I love SAM. I love infrastructure as code, automation, those kinds of things. So much so that I've been known to wear a Sam squirrel costume and have a dance-off at reInvent last year, in which I won. So we're not doing it this year. I'm going out strong. So I'm a father of 5. That may be kind of confusing to you. So we're going to pause there for a moment. I need to give you the rules. Who's heard me speak before? Okay, a lot of you in the room. Well, I'm going to bore you with the rules again, okay, because these are important. Because if you haven't heard me speak, the rules are going to help you. They're probably guidelines. I say rules, guidelines, however you want to look at it. But the first one, and probably the most critical one, is this is any number I want it to be. Okay? I'm going to hold this up, and I'm going to say 7, I'm going to say 14, and it always throws someone off. I go to the restaurant, table for 7, please, and I'm sitting alone at the bar. Okay? So it's contextual. You got to listen. I can get to 4 if I take my shoes off, but that's weird for everybody. Okay? So we're not going to do that. The second rule is these are quotes, not apostrophes. I know that. Okay? Because this looks better than this. Somewhere in the back, someone's like, is he doing a bunny? No, I'm not doing a bunny. Unless I am. It's contextual, right? So, and finally, these are thumbs, because this will get you beat up. Okay? So, those are the rules. Hopefully that helps you follow along. I was born this way. I did not wake up the first time this way. If I did, I would not be here with you. Okay, I'd be somewhere coping with that, right? But I'm not easily offended. I'm not bothered. I'm very comfortable with this. However, if it makes you uncomfortable, I am also comfortable with that. So just rest assured, I'm okay. All right, so let's get started. We have a lot to cover today. I'm going to go kind of fast, but we'll see what we can do. You want to take photos, you can take photos of anything you want. However, a lot of the resources that I'm going to refer to are on this QR code at the end. I'm already out of breath. I haven't even done anything. I'm like, oh, okay. All right, so I'm pretty excited about this. So, all right, so here's our agenda today. We're going to talk about coupling and what that has to do with event-driven architecture, what we see, and how we can do things about that. We're going to talk about integration patterns that we see in the wild and how we can improve on those. We're going to talk about what is an event. We're going to talk about event-driven architectures itself, and finally, reducing event duplication with idempotency. I just learned to say that word, so see if I got it right, okay? Now, before we jump on this, I want to define event-driven architecture. Anybody working with EDA right now? Okay, a few of you. Good, all right. So we say EDA, you see us throwing that word around a lot, but I want to help you understand what we mean by this as we're going into this conversation. So, this is probably the most technical part of the talk. So if you want to get out a pencil and a paper or something, take notes, you'll want to do this, all right? So here's EDA in a nutshell, okay? Stay with me. Something happens, and we respond. Okay? All right, I'll do it again. I see some of you like, what? Something happens, and we respond, okay? Now, yes, that's an oversimplification of EDA, but it's that idea. A lot of times as we build applications, we're letting everybody know what's going on and calling APIs and all that kind of stuff, where instead we just want to be able to go, hey, I'm going to throw an event out, this happened, and move on. And other people can react to that event. So we'll climb more into that. I'll get a drink of water. It's very dry here in Las Vegas, if you didn't know that. Sorry, I just made a mess there. All right, so let's jump in here. Coupling. Why are we talking about coupling? Coupling is kind of important. So when we talk about EDA, coupling is kind of the opposite of what we want. We don't want things tightly coupled. We want them loose. We want them responding to events and not relying on each other. Okay, so let's talk about why that is. All right, coupling is kind of this integration's magic word. When we couple things together, that's how we're integrating things, and it's, excuse me, it's a measure of independent variability between connected systems, right? Decoupling has a cost at design and runtime. As we're trying to pull things apart and pull the reliability off each other, there's a cost, both at design and runtime. So you need to think that through. It's not binary, and it isn't one-dimensional. There's a lot of different things that happen in this. As you're sitting through thinking about what is coupling, here's some things that I never even thought of. As we're sitting, what are some coupling things we do? Think about your stacks right now. Okay, first coupling, are we reliant on one technology? Okay, where's only Java? Maybe Java isn't the best for this. Maybe Python or something like that. So that's a coupling. We're locked in. Location, IP addresses, DNS. This is an important one. A lot of times we're locked into using location. If that goes down, we're in trouble. Data format, data types, semantics. And I won't go through all of them, but these are good to understand how we start coupling our systems and causing them to be reliant on each other. Gregor Hope, if you've not heard him, he's a great speaker on event-driven architecture, works for AWS. He says this, he says, the appropriate, they pay me to speak right here at AWS. It's shocking, isn't it? The appropriate level of coupling depends on the level of control you have over the endpoint. Now think that through for a minute. How often do we make our applications reliant on an endpoint that we have no control over? And we're building in these some kind of, is it up, is it up, is it up, is it up? You know, we're polling and things like that, but we're reliant on something that we don't have control. And so we try not to do that, right? So the appropriate level depends on the level of control you have. All right, so with that in mind, let's talk through some integration patterns. Some of these may be, yeah, I get that, Eric. Some of these may be, ooh, I hadn't thought about that. So what we're going to do is we're going to look at some integration patterns that we see and maybe some improvements we can make on that. All right, so the first is a synchronous request response model. And I'm sure, how many of y'all are developers? Raise your hand. Okay, all right, good. How many of you want to be developers? All right, good, okay, good. I'm glad y'all are here. So hopefully you've kind of seen this. One of the things we do, when we're developing is we want to get data from somewhere, so we call an API. And we do this synchronous call, and we send a request, and then we wait for a response. We all know this. All right, I send it, and then I'm waiting. Is this awkward for anyone? That's right. It's awkward for your customers, right? We do this synchronous response or request. Now, synchronous has its place. I'm not anti-synchronous, but I am a fan of asynchronous over synchronous. So we'll talk about that in a little bit. But here's what that looks like. We do a request, we get a response. But what happens here, with this, we have some advantages. One is it's low latency. It's quick, right? We get the answer immediately. And we love that, right? Because we live in a world where if you don't get an answer in seconds, it's over. You're moving on. It's broken, right? Okay. Second is it's simple. Make a call, get a response. And the third is, and this is a big one, is it fails fast, right? You know immediately if it worked or not. However, there are some disadvantages. If your receiver goes down, your sender is done, right? And if you don't have control over that API, you're done until they're fixing it. And you're calling panically, and I've been that guy. I've been the developer. They call at 3 in the morning and go, hey, it's down. And I'll say, who is this? All right, I'm not even coherent. So that's not fun. The second thing is, in this type of thing, is you can get your receiver throttled. Okay, as you start, oh, hey, that's a great API. We want to get weather from that. We want to get stocks from that, whatever. And so everybody starts building up on it. And now everybody's dependent on it, and it throttles it. And it may not go down, but it degrades to a point where it's not very good to use. Right? So this is that synchronous model. So how do we fix that? Well, we look at what one aspect, and this is a very common one, is a queue. And I can talk about queues forever. I love queues. I love the idea of batching. I love the idea of efficient coding. But the idea here is I'm going to send a message 1, message 2, or so on and so forth, and I get an immediate response. I acknowledge you've sent this. Now, that doesn't mean I've got the answer back. It has like, yes, the answer is 7, okay? It just means I'm getting that for you. Then I'm going to send it to my service, and I'm going to work on that, and I'm going to send it back, okay? This is an asynchronous pattern, right? So we call this, so this is called the asynchronous point-to-point queue. Now, when we do this, the advantages are it decreases temporal coupling, meaning I'm not reliant on that location. The queue can be up and running. If the receiver goes down, that's okay. Stuff just builds up in the queue. It's resilient to receiver failure, like I just said, and the receiver controls the consumption rate. Now think about that for a moment. If you're just sitting here going, those are great words you said. But think about how many of you work on an old system that the boss says, you need to keep this up and running. It can only handle 3 concurrent connections, but we're getting connections at the rate of 2 billion. And it's your job to keep it up and running. I see some of you going, yeah, that's me. And that's just it. So you have a choice. You can say, look, after 3, so the other 299, I can't even do that math. I can't get past 4. We talked about it, right? So the rest of them fail out. But instead, if I throw a queue in there and I say, hey, build this up in the queue, and then I'll process those as I have bandwidth. Okay, this pattern's very powerful. So the other nice thing about this is you can have, let's say you get some bad, you get a bad actor in your data, right? And you've tried, and our queue can retry things and it fails. I can kick it out to DLQ, which stands for a dead letter queue, right? And so that allows me to throw that out and keep working, but I didn't lose the data, right? The data's still there, and I can evaluate that and see what's going on. All right, so the other cool thing here is with this is only one receiver can consume each message, but you can have more than one receiver. So you can, this is where, and in a pattern, we'll have a queue, and then we have a lambda function consuming a queue, and they can scale up. And they just, we're going to handle that queue and then go away. And so, but the queue manages this by saying, once you do this, and I'll actually get more into this later, but once you have this topic, I'm going to hide it from everybody else so it can't be double done, right? Now, it's not perfect. What we talk about is at least once delivery. Sometimes it's multiple time delivery. And so we have to write applications that are idempotent, and that's why we're going to talk about that a little bit later today. All right, so the others, disadvantages are response correlation. Now, disadvantage may not be the right word. So all your receivers go down, the world blows up, you get the call, but you haven't lost your data, and all this stuff is in the queue. There's some correlation, we've got to get that back up and running. The same with backlog recovery time. But then you also have fairness and multi-tenant systems. But this is easy to handle because you can actually take and build, hey, this is our high priority queue. So we want these to be automatically done. So some of that logic can be done as well, but that needs to be done as you're thinking through your plan. Now, at Amazon, we have a service for this called Amazon SQS. I love this. Look at point number 2. This is my favorite point because I don't have to memorize the number. How much can this handle? What does it scale to? I'm like, basically infinity. Right? Basically infinity. This handles a ton of data. So that's a good one to look at. Same with Amazon MQ. This is a great way to run ActiveMQ or RabbitMQ. If you already have that, you can run this in a managed service. Both of these can invoke Lambda functions and different things. So, all right, so the next one we're going to talk about is a broadcast model. So this is kind of the same idea, still using, instead of a queue, we're going to talk about SNS. We're going to talk about broadcasting to different things, right? So in this pattern, it has one topic that I can publish to, right? And what'll happen is as I publish these, same thing. I get an acknowledgement. Yes, I got it. Now, I'll send it to everybody. And the fun thing about this, we have our different subscribers, 1, 2, 3, 4, and 5, but these can be different types of subscribers, right? And I'll expand on that in just a minute, but this decreases temporal coupling. Again, same basically advantages as before. The subscriber controls the notification, and each subscriber is notified. And look at the type of subscribers there can be. You can have email, SMS, HTTP endpoints, or a Lambda function. And so if you have one topic that needs to, you need to notify people. I mean, I have all kinds of scenarios that I can use this. SNS is a great way to do that. And you can see here it's a fully managed pub sub service for, we say A to A, application to application, and A to P, application to people messaging. Each topic supports up to 12.5 million subscriptions, right? You're probably not going to build this on your own. And why would you? Right? You don't want to have to do the scale on this. This is where AWS just shines, is this scalability. All right, so the next one we're going to talk about is the asynchronous point-to-point model router. Okay, now we see this a lot. So let's say we have our sender, right? And our sender is getting different, they have to send different bits of data. So they have to have the logic. They have to say, okay, I have stuff that goes to the pink channel, so I'm going to assign it pink, and I'll have to call this API. And I have stuff that goes to the purple channel, and I'll have to call this API. I have to look at my colors. I change the colors sometimes when I do this. Like, why did I change the colors? All right, so the advantage or disadvantages of this is this can increase location coupling, right? So now what you're saying is I'm always going to have to hit API 1 for the purple channel and the other one for the pink channel. I need to know where those are, and I'm always dependent if they go down, we're in trouble, right? So in the sender, that's the other thing, the sender maintains the logic. So you have to, if you have a bunch of clients, you have to tell them, okay, here's how it is. When you got to go to pink, you go here. When you go to purple, here. Oh, we've added another color, you got to go here. So there's a lot of communication that needs to happen, metadata needs to happen, that the sender can create that logic. What we want to do is we want to get that out of the sender's hands, right? Because what happens is, as this gets more complex, it causes, you have a bunch of if-thens and switches in your logic, and your code is getting long, and you're writing routing code. And that's really kind of a no-no. In our Lambda functions, we shouldn't be writing code to route data. We should be writing code to transform data, right? So, the answer to this is we use a bus. Okay, you've probably heard us talk about Event Bridge. And the idea here is it gives you one endpoint to send everything to. Just keep pumping your stuff in, right? And if we have multiple senders, you all just dump your stuff on the bus and we'll handle it. And the magic of this is through the magic of rules. What happens is EventBridge looks at this, and we'll expand on this in a minute, but these rules say if you match this particular description, I want you to invoke this sender. So if you're pink, invoke this sender. If you're purple, invoke this sender, right? So this reduces location coupling, and it's efficient for sender and receiver. Your logic is no longer done at the sender, it's done at the bus, or at the rules, actually. And even the receivers can be, they don't need to know about it either, because we just set the rule up to point at them. So when you think about doing that, if you're writing routing logic in your sender, rethink that, okay? Amazon EventBridge, anybody using EventBridge now? All right, good. Super powerful product. We use it constantly. If you've done a serverless espresso, go over there and get some coffee, we use it. If you're doing serverless video, we use it. Everything we do. This is how we communicate between our domains. Okay, so let me talk about how this works. So you have all kinds of senders, AWS services, custom applications. If you have an AWS account right now, you're actually using EventBridge. You have a default bus, right? You have SaaS applications like the brand new Stripe integration. Stripe can actually send information through EventBridge, so can Adobe. Those are two new ones we added this reInvent. And microservices like your custom services or custom applications. Then what happens is they go into the EventBridge. We actually read them. We create a schema registry if you want, so your developers can grab those objects and know what your schema should look like, right? And they come in, you can have different buses, partner event bus, archives, replays, things like that. Then what happens is we apply these rules, and this is where the magic happens. Thousands upon thousands upon thousands of events can flow through the bus, right? But you may only want one or two things to invoke your trigger, one or two types. And they can invoke, and the trigger can be a Lambda function, it can be an ECS container on Fargate, it can be really a lot of different things. And you can have multiple rules be triggered by the same event. So as an event flows through, it can trigger 4 or 5 different rules. So you see how you kind of get this picking what you need and ignoring what you don't need pattern. And then you target, again, like we said, there's AWS Lambda, Amazon ECS, API destinations, all kinds of different things. So I mean, just a ton of targets that you can do. So let me show you what an event looks like. If you're a developer, this is no big surprise to you. It looks like JSON, right? You see in here, coming through EventBridge, you have a source. We can customize that. You have detail type, so on. Then you've got your data. Now, a rule looks like this. We say if your source is com.flix and your region is AU or NZ, then it's a match. Well, look here, com.flix and AU, so it's a match. And so I'll invoke the Lambda function. What you're seeing here is you're seeing hundreds of lines of code being removed from your code base because you're routing where it should be routed, right? This is event-driven architecture. All right, so you have over 30 services that you can do, including API destinations, which allows you to shoot to a lot of different things. And am I talking too fast? Okay, I'll slow down a little bit. I want to be respectful of that. I'm flying, I know. All right, so I'm probably talking too loud too. My wife would be like, yeah, you're talking too loud. So anyway, so that's how we do these patterns, and that's what that looks like, okay? So what is an event? Well, I just showed you what an event looks like, but what does it mean, right? So an event, they're signals that a system state has changed, right? So if you think about it, something happened, and we react, right? And this is that something happened, and it's an immutable event. You shouldn't be changing it because that's a record of what has happened, right? Events occur in the past. They cannot be changed, like I said, and it decreases coupling by restricting information to key data. Now, there's a couple of things to think about when you're planning to use these events. As you're sending them around from system to system, you want to plan ahead. Don't just load everything in and off we go. So let's talk about what sparse events versus full state events looks like. Okay, so a sparse event on the left, a full state event on the right. There's a lot of extra data. So let's say we send a sparse event through to our users. And the example we're using is actually the serverless video system that we've built. All these are real services that you're going to see in here. Okay, so I send that through, and my publisher service says, well, hang on, what's the name of the channel? What channel is that on? My video manager service says, what are the channel tags? I need that information. So my streaming services, what region are they in? This is important to know, right? So what we do is we kind of go, okay, well then let's load all that into it. Okay, let's go ahead and send an event that has all that information. And that's okay, but here's some considerations on that, okay? First of all, event schema should be backward compatible. So let's talk that scenario through for a moment, okay? I see some heads shake. You might have been burned by this before, right? So it's a perfect example. This happened to us. So we're known for sometimes we use camel case, sometimes we use snake case, sometimes we use whatever. So we had an event that had a snake case order ID, order-ID, okay? And that was what being picked up by services. Then we added another service, and they were expecting it to be camel case, order, uppercase D, ID, okay? So, okay, well, all right, well, let's just change that. Now we're not using snake case, we go order ID. Well, now our first service is broken. So instead what we had to do is we had to say, let's add both. So every time you populate, change, modify, stress over, you had to do both parameters. Okay, that's not a huge deal until you're doing it for hundreds of parameters, right? So you want those to be backwards compatible. And so that comes down to the cost to calculate values can increase over time. And cost, yeah, maybe we're talking dollars, but you're also talking time, you're talking developer frustration. That's a cost, right? So these are things you definitely want to think about when you're doing that sparse event. And so the options are you can have when you're doing full state event, you can do a sparse event with a pointer to a fuller event, like in a DynamoDB or an S3 or something like that. So there's all kinds of options you can do. But then again, do you want the time of pulling to grab that data each time? So like all computer questions, anytime you're talking to a developer and you ask, how do you do this, the first thing they always say is, it depends. It depends is our best answer, right? It depends on how you're approaching it, and that's this case as well. All right, so let's jump into event-driven architecture, right? So we've talked a lot about events and how those work, but let's see what event-driven architecture looks like, kind of taking these use cases and applying them. And to do that, like I said, we're going to talk about serverless video, which if you saw me, I was running around doing videos up front there, and y'all were great. You were doing thumbs up, one finger up. It was awesome. And it's posted here. So if you grab this, you'll go see that video. And this will be on the resource page as well. All right, so when we're building event-driven architectures, we choreograph event between domains, okay? So when you think about how you break down an application shouldn't just be one lump sum, because often many teams are working on this. So you have domains. They take care of reporting. They take care of orders. They take care of fulfillment. They take care of video processing, so on and so forth. But somehow you need to communicate between these domains. So choreography between these looks like this, okay? So this is a non-event driven. A lot of times, this is how we build our applications. So we have a channel service, we have video streaming service, video managed service, publisher service, and we have a new channel come in. So what we used to do is we used to have, the new channel service was responsible for notifying each service. Hey, I got a new channel. Oh, hey, I got a new channel. Oh, hey, I got a new channel. Oh, hey, I got a new channel. I got a new channel. Right? And so as we add more and more services, this doesn't seem to make sense, right? We don't want them to have to notify everybody because you're putting the cognitive load on that service and those developers to know every time you have it. And as your team gets bigger, unless you're doing it better than we are, which you may be, you probably aren't communicating that great, right? You're expecting everybody just to know what you're building. So instead of approaching it this way, instead we can do an asynchronous broadcast model, right? So what we'll do is we'll set up a topic, and we tell everybody, if you want to know about new channels, subscribe to that topic. If you don't want to know, then ignore it. So when a new channel comes in, everybody's notified through their subscription, and the channel service doesn't even know who's getting these. They don't care. They just know they did their job, tossed an event. And people laugh at me, but that's like the architecture of EDA. Apart from something happens, we react, do your job, and toss an event. And that's how we choreograph, right? So let's look at that here with the router model. Okay, so that was the topic model. If you have some, you may want to do it this way. You can do it with the bus as well. So a new channel comes in, you kick an event onto the bus, and this tends to be my preferred. I really like EventBridge. I like all the services. This is being recorded. I like all the services equally. I feel like they're my kids. I have 4 kids and another kid. So, all right. So you put this in, and as the bus goes through, we trigger these rules, or these rules trigger these services. So here's another way to say, you get one, you get the other, you get the other, right? So again, this idea of we orchestrate the business process within the domains, right, and we produce one or more event. Right, so let's talk about that here. So let's say we have these 2 services. We introduce 2 more services, the video post-processing service and the plugin manager. Right? Now I'm going to go back for a second. So we have this idea here of these domains communicating with each other on the EventBridge bus. Okay? So as they're communicating, we say, wait a minute, we've got 2 more services. How do they communicate? Well, if you look in here, like this is our video post-processing service. This is actually the post-processing service. I'm showing you the real behind the scenes here. And in this, it's kind of cool. I'm going to take a sidebar for a moment. And in this, we are choosing which compute to use. You see my shirt says better together. What we're talking to people about is sometimes Lambda works, sometimes EC2 is a better choice, depending on how it goes. In this process, we're looking at this and we're evaluating a video that comes in, and we look at it and go, that's pretty long. Let's invoke an EC2, an ECS instance on Fargate, right? Okay, so now I have a container running on Fargate, and it only runs for the length of time it takes to run that video processing. Or if it's a shorter video, it makes more sense to bring it up on a Lambda function. So really honestly, we're building these hybrid orchestrations. And then the other thing with this orchestration using step functions, we use direct integration where possible. We're talking directly to DynamoDB, we're getting items, and dramatic pause for effect, and a drink. we're kicking out an event. All right? So again, think about this process. Let's do some, and it may be nobody reads this event right now, but somebody will, it's just a, hey, this is done. It's out on the bus in case you want it. We do a thing, we produce an event. So the same thing with our plugin manager, and this is a really cool system. Ben Smith wrote this out with step functions, where he's running these different plugins based on where it needs to happen. And I'd love to spend a lot of time to talk about this, but I can't. But each step, he makes sure they happen in order, and he's using the DMAP, distribution map in step functions to do that. And he's doing a lot of things, but when he's all done, he's producing an event. Right? So this is how we choreograph. We're orchestrating inside the domains, and we're choreographing between the domains with Event Bridge. The orchestration we're using is all with step functions. Anybody using step functions now? Okay, super powerful product. Okay, I'm going to be honest. That's my go-to product. That's where I start with, because almost always I have to do more than one thing. Okay, if I'm doing one thing, I tend to do direct integration with like API Gateway, even to DynamoDB. But if I have to do multiple things, and a lot of that, there is business logic. So I will have my step function invoke my Lambda function and get the data back. But that helps me not have to code for orchestration. All right, you can see here, direct integration with over 200 plus, 10,000 APIs, doing a lot, including Bedrock. We just announced that this directly integrates with Bedrock. So if you're doing AI, Gen AI, those kinds of things, that'll work. All right, so again, and I know I've said this a lot of times, but I want to say it again. Choreography and orchestration together help you build these distributed apps. We know at AWS, we know distributed computing, distributed apps are hard. They are. Building in redundancy, building in resiliency, it's hard. So we've said we're going to make it as easy as we can for you. So you build in, you choreograph between them, the services, and you orchestrate, and this works, right? So let's apply this again. We're talking about serverless video, so I'm going to show you some of the works that are going on. I just want to show you the architecture. And you can see here, we have the different services, and we have our domains, right? We have our channel service. We have our video streaming service, our video manager service, our publisher service. There's a plugin service there as well. And they're all talking with events. And the event bridge is the core to the whole system. We're throwing out events. We produce something, or we do something, we produce an event, and then other folks are reacting to this. And the really cool thing about this is if someone comes along, which this happened to us, it happened last year, or the year we did Serverless Espresso, 2 days before reInvent came along, someone came along and said, you know what you should do? It's like, what? You know, you should have a history of how everything went through the service. Well, it wasn't that hard to build because all the events were there. So we just added another service that collected those events, ordered them, and we were done. Okay, so it's a modular way of building these applications. Okay, so the last thing we're going to talk about, and it takes the longest, so we got some time here, is we're going to talk about idempotency. Now I'm going to tell you a story. Just before pandemic, I was doing a trip where I was going to speak in Turkey, which I was super excited. I've never been to Turkey, right? And I was super excited, so I go to Turkey, I get off the plane, it's a brand new airport in Turkey, it's gorgeous, okay? And I'm standing in line at customs, and there's like 20 people in front of me, I'm waiting, there's like 50 customs booth, I get up, I'm the first person in line, I hand the girl my passport. Now, I don't know how many of y'all are travelers, but this is a red flag, okay? She took the passport, she scanned it, and she went, and I went, and I said, and I stepped around the glass and said, is there a problem? And she said, get behind the glass. So I stood there. For 20 minutes, she wouldn't tell me what was going on. She was on the phone, stuff like that. Next thing I know, 2 armed guards walk out. And I'm not talking a gun on the side. I'm talking full body armor, AK-99 or whatever, I don't know. Okay? Guns, and they come and they stand on either side of me. And it's literally like, how's it going? How you doing? And I literally said, can I just get back on the plane? Said, no, sir, you cannot. They closed the line behind me, and everybody went off. So they escorted me to a guest room with no windows. And they set me down. Nobody was telling me what was wrong. They were just saying there's a problem. At this point, they've got every ID I had on me. I kid you not, they kept asking me, do you have ID with your parents' names on it? Which we don't do here in the US, but they do over there. I said, I don't. So they've got my mom's Facebook page up, trying to find identification, trying to find links. Finally, after about an hour sitting there, I said, tell me what's going on. And he said, all right, here's the deal. Someone with your same exact name, first, middle, last, is flagged and not allowed to cross the border. And I'm like, I'm not him. They said, okay, you can go. No, that's not what happened. Here's what I said. I said, let me ask you a question. I said, do you have prints on this guy? You're getting it. And he said, of course. I mean, he was very haughty. Of course we have prints on him. I said, if you got more than 2, I'm not your guy. And it was, you can go, Mr. Johnson. You see, they had duplicates in the system. They had me and somebody else duplicated, and I almost went to jail for it. They were not dealing with idempotency. I'm sorry, they were not building idempotent applications. So I'm going to give you some tips on how to restrict this. So we deal with duplicates of systems all the time. That's just the way things go, especially with distributed applications, because a lot of the services do at least one-time delivery, right? So we have to build our applications to be able to say, is this the same or is it not? So, and I'm not going to tell you this will make it so you never have to dedupe your database or something like that. There's some things you can do on that as well. We'll have to do another time. But we're going to talk about how do we build idempotent applications that don't even write to the database, that we can keep it from doing that. All right, so first of all, let's talk about what is idempotent. And when I first heard about this, I thought idempotency was a bad thing. I'm like, oh, there's idempotency in my application. Get it out! Right? Idempotency is a good thing. Okay? Again, this is a hard word. I don't even know why we call it this. All right? But the thing is, here's the basic thing. It says operations that can be applied multiple times without changing the results. This is the mathematical definition. Right? Same time, same results. Okay? This is the, again, back to Gregor Hope and Bobby Wolf. It says a message that has the same effect whether it is received once or multiple times. Right? So you want to really guard against that. But let's get to the real definition, okay? This one comes from my mom. Was my credit card charged twice? I don't know how many of you have gotten that call, but I have. Something broke, I don't know, and yes, I've been charged twice. And you don't want to be that company that does that, right? So let's talk first of all, where can duplicates occur? And so when you think about building your application, there's a lot of different places that can happen. So, first thing is transmission issues. All right, so let's go back to our synchronous. So synchronous requests are not innocent of this. They have the same problem, right? So if you think about how a synchronous message works, you're going to send the message, your receiver's going to acknowledge the message, and then that acknowledge is going to time out. It never got back to the sender, okay? So the sender is going to have a timeout. Hopefully in your code you've said, I never got a response, so I'm going to try again. And we're going to send a message, and now the acknowledgments work. Problem is, now we have a duplicate message. We don't know, as the client, did the receiver even get my request because it never got acknowledgement. So it could have not gotten it and you don't have a duplication, or it could have gotten it and not responded and you have a duplication. You don't know. Okay? So, second place this can happen. This is receiver issues. Right? So, when we set up, now the example I'm going to use is an SQSQ. Okay, I'm going to kind of tell you how this works. So when a sender sends something in to an SQSQ, for redundancy, we automatically make multiple copies of it. We handle that for you, right? Then When your sender, either we invoke a Lambda function, the Lambda poller grabs that, or however you're doing it, when they grab an object off of the queue, what happens is SQS hides that message, hides all the copies, so that nobody else can grab it. It doesn't take it away, it just hides it. It's called, you probably see the timeout value, right? Which is on the developer test, okay? Which I passed, but I didn't get that question right. So now I know I can do that test now, right? So when that happens, so then what happens is if that receiver fails, you've got a problem here. After a while, that timeout value is going to say, let's go ahead and show that again because it doesn't seem like we've gotten an acknowledgement back to clear it out. Because that's what the receiver should do. When they get the message, they process the message, then they let SQS know 200, everything's good, take it off the queue. So what happens is the queue says, all right, let's go ahead and make those available again, and another receiver grabs it. So now we're back to the same question. Do we have a duplicate? How far did receiver 1 get? Did it save the data? Did it process it? Did it ever get it? We don't know. So this is important. So that's what happens in receiver issues. The other place this can occur, yes, it is true, it can happen at the service, right? So Werner Vogel says this. He says, everything breaks all the time. That's just reality. Okay, if you don't know who Werner Vogel is, I'm sorry. No, he's a CTO, a very sharp guy, has some great sayings and some great t-shirts. So something at AWS is we build as if to never fail. But we plan knowing we will fail. Something will go down. It's computers, it's technology. It stops working sometimes. This is going to shock you. Eric Johnson's code is not the best. My code goes down. My code's the biggest liability you could ever have. It says developer advocate because that was like a template. It should say hack developer advocate. Okay? I'm an architect, all right? So services go down. So let's take that example here. So we have our sender. They send data to the queue. Again, we know it's going to do triplicates or whatever, so we have redundancy. Our first receiver grabs it, but while the receiver's processing it, the service goes down. Now, like I said, we make duplicates so that if the service goes down, you still have your data. So availability and durability, right? Two different things. The service may not be available, but it's durable in the fact that your data's still there. Reliability, whatever ility you want to throw in there. Okay? So receiver 1 says, so again, we're back to, did receiver 1 get something? Did it process it? We don't know. So then receiver 2 is going to grab a service, it's going to hit a different endpoint, and it's going to process this, and now we possibly have duplicates, right? Sorry, I'm just really dry up here, folks. Okay. So we've got this possibility of a duplicate. So how do we do this? Right? So let's talk about some processes to kind of avoid this. First thing, and big thing is idempotency tokens. Anybody doing that now? Okay, good. A couple of y'all. Anybody familiar with power tools? Okay? Just had breakfast with the power tools team this morning. They are phenomenal. Okay? If you're not familiar with power tools, how many plan to look at it when I'm done talking? Okay, keep going. Keep going. Yeah, it's going to help. It's going to help you, not me. Okay, I don't get paid for this, but I really encourage you to check out power tools, and here's why. Okay, the pattern I'm going to show you, power tools does automatically for you in a Lambda function. All right, so you have this pattern where we use idempotency tokens. Now, a couple things to understand about idempotency tokens are they are uniquely identified messages. They uniquely identify messages to enable receivers to avoid duplicates. So we're trying to avoid what we just showed, right? Number 1, they should be generated by the client. So the client needs to know what it is, right? Because this is who's sending it out. Number 2, they are resent by the client on retry. If a client times out and needs to resend it, don't generate a new one. Use the same one, because this is a transaction identifier, okay? Number 3, they are unique per message. So if it's a new transaction or a new message, it's a new UUID. And finally, use a dedicated field. And I'll explain that in just a second. So here's the pattern that we do with an idempotent request using Power Tools, okay? First thing is, when you set this up, you put it in Power Tools, we create a persistent layer. The persistent layer we use is DynamoDB. This can be a lot of different things, but we use DynamoDB. And here's how it works. The first thing we do is the client calls the Lambda function. It invokes the event, and it sends a token. The second thing it does is the Lambda function then looks to the database and says, does this token exist? Have we already tried this action? No, it doesn't. Okay, write it to the database and lock this transaction, meaning this is what's going on. Second thing it does is it runs your handler. Whatever code you have, we're going to invoke that handler like a normal thing. And then the third thing it does is it updates that record in DynamoDB with the output of your handler. Okay? So it's not like, oh, it's just this little bit of data. It's taking the entire output and it says, here's what the response I'm sending back to the client is. Finally, it sends that data back to the client. Okay? So when we do that, the client gets it, they're happy. So let's look at what happens when it doesn't work. Okay? So let's say that response doesn't get to the client. So as a good client, we have a timeout and we're going to retry that. We send it again, but we send the same idempotency token. We say, this is the event, we're still in the same event. This system, the Lambda function looks up the record in DynamoDB and says, oh, hey, we did that already. We have this identifier in the database, so take the response from last time and return it to the client. Do not invoke the handler. Okay, you following me on that one? So what happens is, just like we defined, you get the same response trying over and over. Right? So this keeps us from writing new data to the database because we've already done that. All right, so that's how idempotency tokens work in your code. This is a good way to approach that. So I want to also tell you how we do idempotency in our services. You see how they act. Okay? So the first one we're going to look at is SQS, and this is a FIFO queue. FIFO stands for first in, first out. So this queue can keep an order for you. So you see here, if I were an AWS CLI, I would generate a token using some kind of UUI gen or something like that. You get a token. And then I'm going to send a message to the queue, and I have my queue endpoint, and I pass that token as the message deduplication ID, right? And then I pass my message body and some other information. I get this back, and you'll notice the message ID in the first response is 9CE, whatever, going on forward there. I can send the same message again with the same token, and I get the exact same message back. So SQS knows this was a repeat, and it's okay. This is an idempotent service. Right? So the next service we look at is step functions. In step functions, we do the same thing again. We generate a token. The step functions, this is just the name of the step function, right? So different services have different names. And sometimes you're responsible for naming it, but different services use different names. So in this one, we generate the token. We pass that token as the name. When we get it back, you can see, and it's in the ARN this time, you can see the very end, the matching ID. So that's in the resource name. And so this is an idempotent service. So you're not going to duplicate using this if you use that technology or use the name. And step functions will actually force a name. If you don't name it, they'll create one. But it's better if you're automating this, think about that when you're passing the name. All right, so let's look at EventBridge. So EventBridge, again, we're going to pass some data in. There's not a token or anything here. We're going to push that, and we get an event ID back. We're going to push the same event again, and we get a different ID back. It's not idempotent. Now, you might be thinking to yourself, it's like, well, we got it all built, and we went, oh no, we forgot to make it idempotent. are bad. No, here's the issue. Events can be when you're using EventBridge, you may send the same event back through. They may look just alike. So it's always a new one, right? So how do you make EventBridge idempotent? Let's talk about that. I almost lost the remote. It's right here. I got it. Okay. So what we're going to do is we're going to use an idempotent token, okay? But we're not going to use event ID, okay? Because that can confuse things and it may not go all the way through. We're going to create an idempotent. In this, we'll call it idempotency key. We can name it anything we want. We can name it Bob, right? And we put it in the metadata, and so that'll get passed to the client. Now, there's a couple of patterns on this, but one thing you might do is you might write this to a DynamoDB as just a key value store, and then your client can look it up and see if something's happened. Does this already exist? And there's a lot you can do. But basically, this passes through to whatever target you're working with. And so when you build it out that way, then you're able to make EventBridge an idempotent service, right? Okay, so again, talking about idempotency tokens, watch out how you pass them through systems. Again, I really want to encourage you, don't just use standard names. We see this all the time. As you're passing things through a system, let's say we set up an application where we say our sender is going to send a message to the receiver, and we're going to use the ID of message ID, and we're going to say 1, 2, 3. And our receiver is going to process this and send it back, and it'll have a correlation ID of 1, 2, 3. And our sender says, oh, okay, that's the one, we're good. 1, 2, 3 equals 1, 2, 3. But with distributed applications, often you have some type of intermediary service, right? So our first service sends a message ID 1, 2, 3. Our second service also uses the name message ID, and it changes it to 4, 5, 6. So our receiver gets that and says, okay, I'll do the work. Now I'm going to send it back with the correlation ID of 4, 5, 6, and it is not a match. Okay, so be very specific on what you're naming your parameters and make sure they're unique, right? So that's going to take some communication. But if you'd be shocked how many times we see this, right? It's like, well, nothing's working. Oh, well, wait, all the data's there, and so it's not correlating. So I really encourage you to, just when you're doing that, just be real careful how you're lining that up. And with that, that's how we approach idempotency here at Amazon or at AWS. That's how we do it in our services. We have power tools that helps you do idempotency when you're building your applications. And I really challenge you as you're building to write that in. As I promised, I would give you, again, here's the resource. I'm going to give you a couple of resources before we say goodbye. This is the resource page for this one. This is on serverless LAN. I'll give you a moment to grab that. And then the next resource I want to give you is actually serverlesslan.com. This is really cool. If you're looking to get started with serverless or you're looking for a specific, hey, how do I start? We have this thing called patterns. Anybody seen serverless LAN patterns? Oh, you're going to love me, every one of you, when I'm done here. Basically, what you do is you go up and you go to the patterns page and you say, I need to connect DynamoDB to this, or I need to connect API Gateway to a Lambda, and it'll show you the pattern in CDK, SAM, Terraform, those kinds of things. So check that out. The last one we have is the serverless video. We have the recording. I showed this earlier. And then if you want to continue AWS Learning Services, all kinds at s12d.com, serverless learning. And with that, I'm going to say thank you, and I'll answer any questions. I really encourage you, fill out the form. Let us know how we're doing, our feedback. And thank you very much.